Hi, I'm Anthony, and I'm going to show you how to make caramel candies. And first step is just to get your ingredients ready. Your first ingredient is sugar, 1 cup of white granulated sugar. That's 7.5 ounces. Ingredient number 2 isn't quite so obvious. It's a 1/4 cup of light corn syrup. You're probably asking, well, why corn syrup? Let's find out. This is sucrose, aka table sugar. It's made up of a bunch of carbons and some oxygens and some hydrogens to fill the clutch. And as you probably already know, sucrose has a tendency to form crystals. And you can heat those crystals up or dissolve them in water and it becomes a liquid. But as soon as it dries out or cools down, it's going to become a crystal again. And if you're making candy with sugar, sucrose, then that's going to lead to a sort of grainy, sandy texture in your candy. And you don't want that, especially in caramels. So, one method to prevent the crystallization of sucrose once it's in a liquid form is to introduce some sort of acid like lemon juice or cream of tartar. And what that does is split sucrose down the middle into glucose and fructose, which won't crystallize. Unfortunately, since acids taste a little sour, you can bite into a lemon if you want to test that, your candy's not going to be as sweet, and you probably want your candy to be sweet. So, another solution to prevent sucrose from crystallizing is to introduce something else that prevents these sucrose molecules from touching each other and actually forming crystals. Sort of like creating a barrier around the molecules so that they don't form crystals with one another. And that's where the corn syrup comes in, and I'll demonstrate. Let's suppose these 3-dimensional blocks are sucrose molecules. When you push them together in one space, they have this tendency to form a crystal, a sugar crystal. But if you tear them apart by melting them with heat or dissolving them, and add something like, let's say, corn syrup, then pushing them together, the corn syrup interferes with these molecules' ability to recrystallize. And so you don't get this grainy texture as if you were biting into a sugar cube. You get a smoother texture as if this were still a liquid. And that's what you want for a caramel. And the nice thing about corn syrup is that it's mostly glucose anyway, so it'll add sweetness to your candy and also be completely flavorless. Next ingredient is 4 tablespoons of butter. That's half a stick. And the fat will serve a similar purpose as the corn syrup, and the salt will accent the sweetness. And this is salted butter, so that's alright, but if you're using unsalted butter, you're going to want to add about a 1/4 teaspoon of this stuff. And your last big ingredient is going to be 1 cup of heavy cream. Again, that's more fat to prevent recrystallization of the sugar. Plus, the proteins in the cream will react with the sugar and create that dark brown caramel color that is characteristic of caramel. Plus, it's pretty tasty. Vanilla extract is an optional ingredient, but it adds a nice flavor. Start off with a glass pan, about 2 quarts, be the size you want, and line it with either parchment paper, wax paper, or aluminum foil. Any of those will work. But if you use aluminum foil, you're probably going to want to grease the aluminum foil once it's in the pan, just to guarantee that your candy won't stick to it. Sometimes I have problems with aluminum foil, and sometimes I don't. So with ingredients on hand, grab yourself a fairly large size cooking pot, rubber spatula for mixing, and then start tossing in your ingredients. Just one after the other. But the only thing I would hold off on is the vanilla, because if you cook it too long, then you'll cook the flavor away, and then what's the point of even adding it at that point? So remember, save the vanilla to the end. Add in the corn syrup. Turn the heat on to about medium. Okay, so it looks like my butter is about melting, so now I'm going to add this to the pot. This is a candy thermometer, and it's absolutely vital for this process, and I'll tell you why. So you may or may not have realized it, but the cream and butter that you have in your mixture have moisture to them. They have water in them. And water changes its state at 212 degrees. It becomes steam, it evaporates. So liquid water itself will not get above 212 degrees because it turns into something else at that point. But your candy in the mixture is actually going to want to get much hotter. The sugar will get way hotter than 212. But the water in it, because it has this 212 cap, is actually going to cool down the whole mixture. So as water evaporates, the less water you have, the less cooling you have. And the less cooling you have, the hotter your candy can actually get. And it turns out when your candy is about 250 degrees, maybe a little bit lower than that, then enough water has evaporated to create the perfect proportion between water and sugar, to where if you pour it out and let it cool, you can cut it up and there'll be solid pieces that you can hold in your hand, but they'll still melt in your mouth. So I've got my candy thermometer in, and you want to make sure this little nub, the point that actually reads the temperature, is not touching the bottom of the pan. Otherwise you're going to get a reading on the pan and not the liquid that's inside the pan. And it's not such a problem with this model because it had this little foot on the bottom. But it's just something to be aware of. And this just clips to the side here. So something to note is that once it gets to this boiling stage, mixing it too much will help those sucrose molecules find each other and reform crystals. So you want to minimize your mixing, but you still want to stir it a little bit just so that your things are even and so the thermometer will get a reading on the average temperature, not just the temperature at the side of the pan. So check this out now. I'm about 20 minutes into the cooking process and it's almost done. It's almost reached 250. This is way thicker. It's got that dark amber color from the proteins in the cream reacting with the sugar. So it's looking a lot more like caramel and it's smelling a lot more like caramel too. So this is all a good sign that things are going according to plan so far. Just a few more minutes. Alright, we're just about at 250 here. I turned off the heat. I'm going to add about a teaspoon of vanilla. Mix it around. Give it a final mix. And take this bad boy off the stove. Alright. And pour this into the prepared pan. I'm going to do it pretty quickly. This stuff hardens quite fast. In the meantime, you'll remember the pan we cooked in is now coated with hardened caramel, and that's going to be a pain to scrub. But this is just sugar and fat, and it'll melt with heat. So if you fill this thing up with water, put it back on the stove, heat the water up to boiling for a little bit, it'll practically clean itself. This caramel now is about halfway cool. I can tell because it's still soft in the middle, but when I lift it up, it holds its shape. So I'm going to pull it out of this pan, away, and use this time to do a little bit of cutting and shaping. Of course, you can cut this just straight. I'm going to cut it at an angle, though. That way, I can make some nice diamond-shaped pieces. Alright, let's review. Sucrose equals glucose plus fructose. Sucrose forms crystals that you normally don't want in your candy because it forms a gritty, sandy sort of texture. You can prevent that with corn syrup. Corn syrup plus sucrose will prevent the sucrose from actually forming crystals once the sucrose is in its liquid form. 250 degrees is known as the firm ball stage. It's perfect for caramel. It represents the perfect combination between water and sugar. Very much higher than that and you get a really hard candy. Very much lower than that and then you get a soft caramel sauce that never hardens. Protein plus sugar over a heat source causes a chemical reaction which gives us the caramel color. And new concept, candy equals delicious. So if you have any tips, know any tricks, have any questions, leave a comment, let me know. Otherwise, happy cooking!